Our scientific power has outrun our spiritual power. We have guided missiles and misguided men. That is definitely true when he said it, and it's still true today. All right. Uh, First group to be graded by me. Last name A and B. Last name starting with the letter A. Last name starting with the letter B. Come on, move it. Step again. Okay, thank you. Let's go. Go, 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 go. Okay, good. All right. Last names A and B. Nice. Okay. Farmer Jones. Okay, good. Good. Okay, nice. Good. Wow, big diagram. Nice. Good. A through B. Let's go, you guys. Move it. All right. A through B. Are you the A through B group? Okay. Okay, A through B group. Speak now or forever hold your peace. Okay. One more. No, A through B. Yeah. Alpha Bravo. That's it. Okay. Homework. Last name A, last name B for Bravo. Okay. All right, the rest of you, send it to the aisle. You guys at the aisle, send it on downhill. And man, what a week it has been. All right, these are mine. Okay, send them on downhill. Let's go. Send your homework down. Come on, send them downhill. Come on, hurry up. You're holding up progress. Everybody should be sending them. All right, there we go. Okay. Uh, Bring it up here. Okay, see you later, man. All right, thanks, man. Yeah, thanks. Where's your guys' papers? Uh, you ready? Yeah, you can bring them on over. Just stack them over here. You see this stuff? This is hand desanitizer. If any of you ever become school teachers, what you want to remember is And no offense to anybody here, but handling student papers, they're loaded with germs and you can get really bad illnesses. So when you're handling papers, make sure you desanitize your hands afterwards. Let me get the answer key here, which is here. Okay, good. We're going to try to do a little bit of document camera work. But before we do that, and we're going to have a clicker question here in a second. I want, shh. We got a lot of stuff to cover. Let's get down to business. And I'm just going to review visually and with a few comments. I'm not going to do any of the calculations for your homework. Your strategy for everything, including the bonus, was encoded partially in this diagram from the textbook. Everything. Everything that I'm going to show you about the bonus is basically in this one, although this is a triangle, not a quadrilateral. Okay? Other than that, yeah, it's all in this diagram. So we had 4 vectors, one of them not given. You had to figure that one out. They form a closed quadrilateral. Now what that means is the sum of all 4 vectors has to be equal to 0. It has to return to the origin. You know, you post one vector, post the tip to the tail of the next one, tip to tail of the next one, tip to tail of the 4th one should bring you back. The tip of the 4th one should lock onto the tail of the very first one. In other words, back at the origin. Vector A had a magnitude of 4.70 kilometers. So there's 470 pixels. And a tilt angle of negative 7.5. Now, they didn't write it as negative 7.5, but that's how I'm going to describe it. And, you know, on your diagrams and stuff, you don't have to label it as negative 7.5, but I'm going to do it in my calculations that way, which you'll see. Vector B, 2.48 kilometers, so it's a little shorter. There it is, 248 pixels. And this one's tilted at 16 degrees west of north. So I made that 106 degrees from the x-axis. All right, so this one's up in the second quadrant, if you will. Vector C, the other one given, magnitude 3.02 kilometers. So here's a 302 pixel arrow, and this one's tilted all the way over, almost out of the second quadrant. Okay, so it's 161 degrees. All right, now you have a diagram, so I'm just, kind of going through how they construct the diagram. The diagram's already made for you. What you have to do is rearrange tail to tip, as I mentioned. Here we go. First, you got to decide on where you want to anchor it. So that's my origin there, the red crosshairs. All right, so I'm going to park my big vector A with its tail right there at the red one. All right, so there they are. So there's the 3 sides. Now the 4th side is right here. That's the one that we want to figure out. If you look at it, it's a 3rd quadrant vector. So the components are going to be negative and negative. I mean, if you don't know anything else, hopefully you know that. And that's a simple check. It's not a guaranteed 100% check. But if you came up with positive and negative, or negative and positive, or positive, positive, you should tell yourself, ooh, I goofed up somewhere. Okay? You should come up with negative, negative here. All right, now, the 3 constituent vectors that we know, you want to calculate the components of each. All right, so you basically, you're thinking about this right triangle in blue. Now watch what I do. This is significant. I can draw that right triangle inside there, but I'm going to draw it outside like that. Same triangle, 180 degree flip, and it's outside. Right? Now, second, this is vector B in yellow. There's its component right triangle. And again, I'm going to flip it so that it is outside. Doesn't clutter up my diagram as much. Okay, but it also helps me see something. But you can't see it yet because we got to get the other three. All right, now, vector C, pink. There it is inside. I'm going to flip it around to the outside. Okay, we're good on that. So my component triangles that help me figure out D are all there. Sine and cosine, out the wazoo. And you know what? I was going to give you a talking PDF of one of the examples in the book, but it was so thorough, I just thought, I'll just let those guys use that example. And if you follow the example in the book, you can get every single one of these components. So for instance, for vector C, you're going to have a positive y component and a negative x component, hopefully, if you do your calculations correctly. And then here's the last one. From the other three triangles, you figure out this one. And again, I'm going to orient that out here. Now, do you notice anything about that entire diagram? It's not a square. It's not a square. It's not a rectangle. Not yet. What do you need? How about this baby up here? How big is that one? How big is this baby? The width of that one is the x component of vector B. The height is the y component of vector C. Now you've got a rectangle, and you know the entire enclosing area in red. But wait, there's still more. You know the dimensions of each triangle. 1/2 base times height. Bing, you got 4 areas. And the little brown rectangle there, you got the dimensions of it, length times width. Bing, you got those babies. So that means you can subtract them from the big red rectangle, and ding, 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 there's your answer. And I was talking to somebody, wait a minute. Anybody remember getting 9.8? You did? Good. You know what? I was hoping to see a lot more hands, but did you? Yeah, 9.8 for the air. Okay, good. Um, shh, 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 shh. The components tell the whole tale on this thing. So, and let me also share something with you. I was talking to some students. I was wandering through the tech commons this morning, drinking coffee and trying to compute. And I saw a bunch of students diligent, working really hard. And they said something, well, Dr. B, I heard there's a formula that you use for the area. So they haven't figured out exactly what formula to use. But you don't need a formula. You need to think and analyze and then put it back together and use two simple formulas a bunch of times, and then you got it. Can you not sit in the aisle, please? Come on down. Yo, come on down, have a seat. It's all right. I don't want you to sit in the aisle, though. Just make yourself at home. It's good. You're not disturbing anybody. So just find a place to sit. So remember that. And remember that if you want to get an A on my exams, midterms and final, you're going to have to think. And this is analytic thinking, pulling something apart component by component and then putting it back together in a slightly different way and coming to a new answer that you know you need for which you need the answer. Okay, and a formula, I don't even know if there's a formula for a quadrilateral like that. There probably is, but oh my goodness, talk about making mistakes. But if you can, if I ask you this same identical question on the exam, um, all you got to remember is 1/2 base times height and your basic trig, and then length times width possibly. And for the example that I showed you at the start of class, that's a triangle. You don't even need to do any, you don't have that extra little rectangle to fill things in. So, all right, clicker question. Uh-oh, let me pause the YouTube for a second. I forgot to start. Okay, you should be on frequency DD. Uh, hit the refresh key if you want, or turn it on and off again. You should get a Go Nitro message and be ready to click. Um, Here's your question. You fling a metal spoon straight up in the air. Oh, let me. Oh my goodness. Okay, don't vote yet. Hold on. There we go. Okay. Read carefully. Move this thing out of the way. All right. And I might ask you a question like this. This is a multiple choice question, but you have to think. Think carefully. Let me see. We're getting a mix. This is good. I'm glad I asked this question. This is basic. 10 seconds to vote. Starting now. 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. Okay, good. 247 people. 248. All right. Here's the results. Let me see if I can make this bigger. Hold on. I can't make it bigger. All right. Here's the results. Shh. Come on, we got a lot of stuff to talk about. There's basically a competition between A and C. All right. Now, more people voted for C, and actually, C is correct. Now, why is C correct? Here's what you want to think about. The change in the y component of the velocity is due to the acceleration of gravity, g. And that's negative 9.8 meters per second squared. All right? You've got 20 meters per second to start. That's how fast you fling it upwards. All right? So that means you want your delta Vy. If you say, okay, to the top of the arc, I'm going to lose all 20 of those meters per second. All right? Then that tells you what delta Vy is. All right? And you already know what G is. That's negative 9.8. So you can figure out delta T to the top. All right? So here's how that would look. Okay? And I didn't put units in or anything like that. This is like doing mental arithmetic. And that's what I'm teaching you here, a little mental arithmetic. So you're losing 20 on the way up. So minus 20 on the delta V side. And then minus 9.8 on the acceleration side, G. So delta T is basically going to be negative 20 divided by negative 8. Now that's pretty close to negative 20 divided by negative 10. All right? So it's about 2. Now that's on the way up. On the way up, it takes 2, and on the way down, it takes 2. You know, because whatever, you know, a free fall trajectory, a ballistic trajectory, whatever you lose on the way up, you gain all of it back on the way, if you return to the same elevation. You know, if it's like, you know, baseball or something like that. All right, so let's go back to this, and just to, you know, reinforce. You know, you're losing all. I thought I had a little bit more discussion here. Anyways, so there's the thing, and here's what you want to remember. For every 10 meters per second of upward speed for Vy, that's about a second of rise time. All right. So, you know, so if you got 20, that means about 2 seconds of rise time, and that means another 2 on the way back down, if you care about that. Sometimes you just want to know how far the rise time is. Oh, and by the way, you know, the projectile motion, we normally neglect friction and air drag and stuff like that for fairly low speeds, because we're not, you know, we're not launching rockets to the moon, so we don't have to worry too much about that much speed. But because we're at fairly slow speeds, the trajectory, whatever it is symmetric. All right? So the arc of the parabola on the way up is congruent to the arc of the parabola on the way back down. So there's mirror symmetry with respect to the very apogee, the very top of the arc, what we call in aeronautics the apogee, the furthest point from the center of Earth. And that's up here at the very top. Get my cursor over here. Come on, baby. Right up here at the top. That's apogee. And so left-right symmetry holds there. And all the dynamical quantities also mimic. The only difference is you're going upward on one side and you're going downward on the other side. So whatever you give up on the way up, you know, it's like the Lord giveth and the Lord, how does that go? The Lord taketh and the Lord giveth. Yeah. Whatever, however that goes, you're give a thing and take a thing away. You're take a thing away on the way up, and you give a thing back on the way back down. Okay? Meter per second for meter per second. Delta T is the same on the way up to the top as it is on the way from the top all the way down. Also, it doesn't the height does not depend on the horizontal component of the motion, and we'll be talking about that today, because that's independent. Okay, so if I launch something straight up with 20 meters per second, or if I kick a kickball upward 20 meters per second and down the, you know, horizontally 40 meters per second, they're still going to have the same rise time and fall time, same hang time. You know, one's going to go straight up and straight down. The other one's going to have a big long hang time down the field. That's a moonshot. 20 meters per second vertically and 40 meters per second horizontally. That's going to go a long way. So we're going to make use of it. Here's another picture. I don't know how they got this. This is a golfer with a, you know, a glowing golf ball, I guess, taking a shot. But you know, those guys, if you actually look at the arcs that, you know, sometimes you see them published, they're not perfect parabolas, but they're pretty close. All right, now let's do this split. We're splitting the motion. We're talking about that in detail today. Galileo's split. He's the one that figured it was kosher to do this. He said if there's no forces acting, just treat it like it's going to go on forever at that speed. All right? And so you can, if you, in free fall, you have a vertical acceleration downward, but you don't have anything horizontal. So he said, look, split them apart and analyze them independently. So, so horizontally, there's no gravitational acceleration, right? Just like Bugs Bunny here says, no such thing as horizontal gravity, Doc. Okay, that's one of my patented sentences. And what that means is that in the equation of motion for the x coordinate, you just got a velocity rectangle, or a distance rectangle, v times t, pretty cinchy. Horizontally, right? Now, let me bring this sound down. I'm a little bit hot on this mic here. All right. So vertically, it's a completely different thing. You've got a constant acceleration. Now NASA's working with vertical accelerations too, and they're not constant. But we're going to stick to good old 9.8 negative. All right. And because that's the case, for instance, it slows upward motion, and you come to a stop at the apogee of your ballistic trajectory, whatever trajectory you're on. And even a planet going around the sun has an aphelion, a point farthest from the sun. It also has perihelion, the point closest to the sun where it's really moving. Okay, so it slows upward motion, and on the way down from apogee, you gain it all back. Okay, so this is the give a thing back part. And it's symmetric. It's meter for meter. The only difference is one's upward and one's downward. All right. So for that reason, we would say that the equation of motion for the y-coordinate is going to be significantly different. It's going to have a velocity triangle, a distance triangle in the formula. Plus, it might, if you launch, like if you kick a kickball, you're going to start with some initial velocity upward. All right, so you're going to have a velocity, a distance rectangle along with a distance triangle. So it can be kind of, and we're going to actually do that on the document cam, work it out and show how all that works. So at the most basic, you have x equals vt. All right, so at time t equals 0, you have some horizontal speed. And hey, you guys, I'm going to use the symbol v subscript 0x to indicate x component of the velocity at time t equals 0 at launch. Okay, because we're going to do a ballistic trajectory and we need some good symbols. Now, there's no such thing as horizontal gravity, so there's no change, there's no acceleration. So it just stays this way all the way through. Now, y is a little bit different. At its most basic, you're talking 1/2 gt squared here, but you might have some initial, like this punter, Ray Guy from the Oakland Raiders, back in the old days when they were in Oakland. The football is going to have some velocity, but it's also going to have the 1/2 gt squared, and we're going to actually work that out. Symbol at time t equals 0, v0y. All right, that's the initial value of the y component of the velocity. Now, the y component is changing. You're losing it on the way up, and you're getting it back on the way back down as negative meters per second. This is the one that changes. All right, so we got two things happening at the same time. All right, so if you think about it, for an upward kick like this punter, he's going to have some positive values, for v0y, and I can just tell you that it's going to be about 20 meters per second for a good kicker, because in the NFL, hang time of about 4 seconds is considered good. All right, so that means you got about 20 meters per second of upward velocity at, when you kick it, plus or minus a few tenths of a second, Now, if you're driving a Ferrari straight off a cliff, and there's actually some problems in the textbook where you're going straight off a cliff, you're going to have V0y equal to 0. Now, that makes things simpler. Then all you do have for your y coordinate equation of motion is 1 half gt squared. You don't have the distance rectangle part. You just have the distance triangle. But we're going to do one that's a ballistic arc, and it's going to be a parabola. Um, and so now here's a picture to go with these symbols. So we're doing a kick. So we have some positive V0y, and as always, we have some positive V0x. And here's the actual initial velocity. So it's tilted at some angle, depending on, what you're, trying to do with your kick and so forth. And so these two parameters, V0x and V0y, go ahead and emphasize those, put a star next to them, because they're pretty important for understanding the shape, the width, the height, the duration of the parabolic arc. Now, I want to go to the document cam, and we're going to work out why those two equations of motion independently set up can be combined and guarantee that it's actually a parabola. Because remember, in Galileo's day, they knew about parabolas, hyperbolas, ellipses, circles, all the conic sections, but they didn't know what a ballistic arc would be until Galileo figured it out. So let me pause the YouTube for a second. Let's go to, come on, books and stuff, get ready to go. We only had one, we're good. We only had one more example I want to do, but it's a situ one. So now, exam one. As I mentioned last time, there'll be some matching for formulas, 1 point each, as we did last time. There'll be some conceptual, possibly brain burner, multiple choice, 1 point each. So bring a Scantron. All right, we probably won't fill up we won't fill up. We might have 20 Scantron questions. Then we'll have 2 problems. All right, one will be basic and one will be a little bit more difficult. Also, we didn't get to chapter 4, so it's only going to be up to the end of chapter 3. And we've covered enough of chapter 3, so just consider chapter 3 to be squared away. All right, so that means basically chapter 2 and 3 for exam 1. You may bring a pencil, bring your Scantron, and bring your calculator. You may not use your cell phone, and be on time. Also, when you get here, I want you to scoot all the way in. Like over here, I see some empty seats over there. I don't want to see any empty seats except at the aisle. All right? Because what we're going to do is I'm going to have pre-counted stacks, one for each row on this side and one for each row on that side. All right? And if you're all squeezed in, we'll be able to get you started as fast as possible, and you'll have more time. If I have to direct traffic and move people around in their seats, you're going to be you're burning time. All right. So the best way to do this is and don't sit in the top row. You guys that are in the row below the railing, and you guys behind the railing, move down here. There's going to be enough seats. All right. So nobody behind the railing and nobody in the very last row right below the railing. All right, and just scoot in. All right, now, I'll be here for a while now. If you want to talk about anything, we're way over. It's 4:24. I'll see you on Monday, and talk to me in web courses discussions. Yeah, chapter 2 and 3 are kinematics.
Well, like any two dimensions. Raspberry skin, right?
Yeah, raspberry flavored scantron.
Like that last parabola example, is that
Yeah, they won't have to do that. So, but yeah, they'll be thinking about that. Some of the things I said in that. So they,
He's MIA, so I was gonna introduce you, but I don't know where he's
it's
at.
good. Whenever he's
But next,
he's welcome anytime.
not by me anymore.
This is the calculator that I used for my last physics. Is this fine?
Is this a graphing calculator?
No, it doesn't do anything.
Is he telling the truth?
Yeah, I used that for the physics 1 and 2 AP exams.
Seriously?
Yeah.
Pretty nice. Yeah, so it looks good.
He seems like an honest man.
Pen on the Scantron? What are you, Pots? You do that? Yeah, you can do it. I've seen guys do it.
Like it won't come out invalid? Like you don't read it through?
No, it'll score it, but
to me my whole life about needing to use a number.
That's what I'm saying.
the number 2 pencil
It's a pink
lie.
Scantron.
You're not supposed to use those. Okay. So this thing that I got is like $10 at Wally's, Wally World.
You said it pink Scantron, right? Oh, no,
Raspberry,
Silvus.
raspberry,
Raspberry,
yeah.
that's what I meant. It's like
Raspberry colored.
you don't have like a study guide or anything for the test?
Study guide.
Study guide for the
Study
test.
guide?
Oh, yes, that's right. This is a high school class.
No. I'm talking about because what you did for chapter 1, you problems that I like, and you set out.
Yeah, I'm gonna have. I am gonna have. I
didn't
gotta.
see any for chapter 2.
Yeah, I
but
didn't do any yet, but I'm gonna. Okay.
it's-
Yeah, and you know what? The ones that I really like are the ones at the end of 3-4.
And at the end of 3.4.
Yeah, 3.4. Yeah, there's a ton of problems, and so, but I have some, noted down, in my
Because he had like
notebook.
example problems due for chapter 2 by the same team.
Yeah, that's right. So so you will have problems that I like.
Okay.
Yeah, I'll try. I know I gotta get to it, but yeah.
Okay, because I've been doing those.
Also, are there gonna be questions from the lab, like the lab questions that we've been working?
Lab
on?
questions, NO. I have no idea about lab.
Okay, so.
And lab they do their labs independently of me.
So you're
All
not
I
gonna
do is
look
get
at
the grade at the end of the
packets and be
semester.
Like I want
Yeah.
to put this question on there, like.
No, I don't.
Okay.
Yeah, so.
Perfect. Thank you.
so-
They can ask.
No, go ahead.
As they're asking, I'm kind of writing down. So they
Oh,
ask
okay.
questions that I like to know.
Your best study resources for the exam would be the homework questions that we
Oh, wait a minute. I'm recording you guys.